Good morning, students. Today we'll finish this exercise 5.1 in continuity. Exercise 5.1. Yesterday we completed up to 19 problems. We discussed x minus step x is discontinuous at integer values of x and continuous at non-integer values of x. Most important problem for objective exams. Next problem. Is the function defined by f of x is equal to 20th? Is the function defined by f of x is equal to x square minus of sine x, x square minus of sine x plus 5 at x is equal to pi. The point is at x is equal to pi. Find the function value first. F of pi value. Pi square, this is minus sine pi plus 5. So pi square minus sine pi value 0 plus 5. So the answer is pi square plus 5. Function value. Find the limit value. Limit extends to pi. Limit extends to pi f of x. X square minus sine x plus 5. It is a substitution limit. First method. Method 1. Put x value pi. So this is pi square minus sine pi plus 5. So this is pi square plus 5. So from equation 1 and 2, what is your observation here? F of pi is equal to limit extends to pi f of x. So limit value is equal to function value. At x is equal to pi, f of x is continuous. At x is equal to pi, f of x is continuous. Next 21. Discuss the continuity of the following functions. Just before going to discuss these three problems, we discussed properties. Let f of x is continuous at x is equal to a, g of x is continuous at x is equal to a, then f of x plus g of x is continuous at x is equal to a, f of x into g of x is continuous at x is equal to a, f of x by g of x is continuous at x is equal to a, f of x minus g of x is continuous at x is equal to a. By using those properties, we'll finish this question. Discuss the continuity of the following functions. Discuss the continuity of the following functions. So the 21st first problem. A. Given f of x is equal to sin x plus cos x. Sin x plus cos x. How this function is? Sum of two functions. Sin x plus cos x. We know sin x domain is R, it's continuous in R. Cos x domain is R, it is continuous on R. So sin x plus cos x is continuous on R. That is the answer. That's all. Just write that one. Sin x is, since sin x is continuous on R and cos x is continuous on R. So sin x plus cos x is continuous on R. This is A. B also you can write the answer directly. Sin x minus cos x. Sin x minus cos x is continuous on R. Already we have taken sin x is continuous on R, cos x is continuous on R. C. Sin x into cos x, f of x into g of x is continuous on R. That's all. One more problems. See that 22. Discuss the continuity of the cosine, cosecant, secant, and cotangent. So already we discussed it. Sin x is continuous on R. Cos x is continuous on R. So all the trigonometrical functions are continuous in their domains. So write this answer for all the 6 functions. We'll write all the 6 functions. So in 22nd, only 4 given. Write the remaining 2 also. We know the domains of the trigonometrical functions. Already we discussed it. First one, sin x is continuous on R. Cos x is also continuous on R. Third one, tan x. What is the domain of the tan x? R minus of is continuous on R minus of x such that x is equal to odd multiples of pi by 2, where n belongs to I. Domain, just write the domain of the tan x. Tan x is continuous on R minus of. Cot x is continuous on R minus of x such that cot x means cos x by sin x. Sin x is not equal to 0. That means x is equal to n pi, where n belongs to I. Tan x definition is sin x by cos x. Denominator should not be 0. So cos x is 0 at odd multiples of pi by 2. Fifth one, secant x is continuous on R minus of. Secant x is 1 by cos x. Cos x should not be 0. X such that set of all elements x such that x is equal to odd multiples of pi by 2. Odd multiples of pi by 2. Next, cosecant x. Cosecant x is continuous on R minus of cosecant x 1 by sin x. Sin x not equal to 0. So x such that x is equal to n pi, n belongs to I. Eliminating those elements, R minus of. So based on all trigonometrical functions are continuous in their domains. Now then, find all the points of discontinuity of f. Find all the points of the discontinuity of the given function. 23rd. Discuss the continuity here. We'll discuss the continuity. In given domain, for given function, discuss the continuity. See the 23rd problem. Given f of x is equal to, given f of x is equal to sin x by x, sin x by x, where x value less than 0, this is equal to x plus 1, x greater than or equal to 0. We have to discuss the continuity of this function. Not on this one. On the real line, 0. When x value less than 0, when x value less than 0, what is given function? Sin x by x. Sin x is continuous on R, x is continuous on R. So sin x by x is continuous on or x not equal to 0. X less than 0 means strictly x not equal to 0. It is continuous. Next, when x value greater than or equal to 0, the function is x plus 1. X plus 1 is a linear function. It is continuous for x greater than 0. Only doubt at x is equal to 0 because right neighborhood function is x plus 1, left neighborhood function is sin x by x. So we'll evaluate the left limit, right limit and function value will decide. Only at x is equal to 0 we have doubt. So first to conclude the conditions, when x value less than 0, sin x by x, no doubt sin x is continuous on R, x is continuous on R, x not equal to 0, so f of x by g of x is continuous. E is continuous. E is continuous. When x value greater than 0, x plus 1 linear function, E is continuous, no doubt. You can generalize the result. Not possible at every point, infinite number of points. So particularly at point, we cannot discuss continuity. So generalizing the condition, x greater than 0. At x is equal to 0. At x is equal to 0, what is f of x function? Second condition, x greater than or equal to 0, x plus 1. F of x is equal to x plus 1. Find the f of 0. F of 0, 0. Function value completed. Find the left limit. LHL. Limit extends to 0 minus. The meaning of 0 minus left of the 0. What is left of the 0 function is sin x by x. Limit extends to 0 sin x by x. Theorem we completed. 1 answer. F of 0, 0 plus 1. Sorry, this is 1 equation. Right limit. Limit extends to 0 plus 0 plus 0 plus. Function is x plus 1. 0 plus 1. 0 plus 1 means it is 1. Let left limit equation 2, right limit equation 3. So what is your observation here? See this one. F of 0 is equal to LHL is equal to RHL. So at x is equal to 0, f of x is continuous. Write that one. At x is equal to 0, f of x is continuous. At x is equal to 0, f of x is continuous. So what is your final conclusion? There is no point of discontinuity for f of x. Write that one. There is no point of discontinuity. Find all the points of discontinuity. Answer is there is no point of discontinuity for f of x. There is no point of discontinuity for f of x. Not on 24th. Try yourself 24th, simple problem. Determine f is defined by f of x is equal to x square into sine of 1 by x into sine of 1 by x when x not equal to 0, x not equal to 0, this is equal to 0. If x is equal to 0, is equal to 0 if x is equal to 0. E is a continuous function. E is a continuous function. So what is the domain? Domain is given to us. When x not equal to 0, in both the cases, x less than 0 case, x greater than 0 case, the function is x square into sine of 1 by x. In both the cases. Here also, x square into sine of 1 by x. When x is equal to 0, what is the answer? 0. Analyzing the function. We have to discuss the continuity of this function. Is it a continuous function? We'll see. Now listen to me first. When x less than 0, x square, polynomial function, continuous on our sine function, x not equal to 0, even 1 by x, it is x not equal to 0. X less than 0 indicates x is not equal to 0. So sine function is continuous on R. So f of x into g of x. When x less than 0, x square is continuous. Sine of 1 by x is also continuous. So it is continuous. Next, when x greater than 0, same logic. X square is continuous. Sine of 1 by x is continuous. So x square into sine of 1 by x is continuous. Write that one first. When x value less than 0, x square into sine of 1 by x is continuous. Is continuous. And when x greater than 0, x square into sine of 1 by x is continuous. At x is equal to 0. At x is equal to 0. F of x is equal to, what is f of x function? 0. So f of 0, 0. Let this is equation 1. When x is equal to 0, second condition number, 0 function is. Find the left limit. LHL is equal to limit of x tends to 0 minus x square into sine of 1 by x. So many of you, here you will do the mistake to evaluate this limit. See how to evaluate, simple logic. X square value 0, see this one. What is the sine of 1 by x value? We don't know. What is sine by 1 by x? We don't know here. But its value always lies between closed interval to -1 to +1. The value which lies between a finite value which lies between -1 and +1. Arrest note on that one. 0 into a finite value. It is a finite value, some finite value. Finite value belongs to closed interval -1 to 1. A finite value which belongs to closed interval -1 to 1. 0 into a finite value, always 0. So this is 0. Left limit value 0. Find the right limit. Same procedure. Limit x tends to 0 plus x square into sine of 1 by x. I'm using same logic. 0 into a finite value which belongs to -1 to 1. This is also 0. A finite value which belongs to -1 to 1. So this is important logic here to crack this question. So difficult, there is no standard limit, there is no limits procedure to solve this problem. Only substitution limit. That too, sine of 1 by x, you should not write 1 by 0. So write the value of sine function, total function. Particularly, we don't know that value. So 0 into a finite value, always 0, using that logic. So here, what is this one? F of 0 is equal to LHL is equal to RHL. So f of x is continuous. F of x is continuous at x is equal to 0. What is your final conclusion? Is it a continuous function? Yes, it is a continuous function for x is equal to r. Write that. F of x is continuous on r. We proved for x less than 0, x greater than 0, and x is equal to 0. So f of x is continuous on r. No, same problem. 25th. Examine the continuity of the f. Examine the continuity of the f. Examine the continuity of the f. Given f of x is equal to 25th question. Examine the continuity of the f. Given f of x is equal to, given f of x is equal to sin x minus cos x, x not equal to 0. This is equal to minus 1. This is equal to minus 1 if x is equal to 0. Examine the continuity of f. At 0, first do the discussion. See this function, how it is given to you. At x is equal to 0, 0. And in remaining cases, x not equal to 0 indicates x less than 0. The function is sin x minus cos x. When x value greater than 0 also, the function is sin x minus cos x. Analyzing the function. Answer very simple. Listen to me. First condition. When x value less than 0, sin x is continuous on r, so it is continuous for x less than 0. Cos x is continuous on r, so it is continuous for x less than 0. So when x less than 0, sin x minus cos x is continuous, no doubt. It is continuous. When x value greater than 0, when x value greater than 0, sin x is continuous, cos x is continuous, so their subtraction is also continuous. Sin x minus cos x is continuous. And where is the doubt? At 0. We'll see. At 0, at x is equal to 0, what is the function? F of x is equal to 0. That means f of 0 is 0. Function value is 0. Function value is 0. Find the left limit. Find the left limit. LHL value. Limit of x tends to 0 minus. X tends to 0 minus. What is the function we have? Sin x minus of cos x. Sin x minus of cos x. Sin 0, 0. Applying this 0. Sin 0 minus cos 0. Sin 0 value how much? 0. Minus cos 0 value how much? 1. Answer is minus 1. Over. Function value are not equal to left limit. It is discontinuous at x is equal to 0. Find the RHL also. Just right limit is x tends to 0 plus x tends to 0 plus sin x minus cos x. So this is also sin 0 minus cos 0 minus 1. Minus 1, huh? Sorry, 1 minute. This is minus 1. When x is equal to 0, minus 1. Now see this one. Function value is equal to left limit is equal to right limit. F of 0 is LHL is equal to RHL. So f of x is continuous at x is equal to 0. So f of x is continuous at x is equal to 0. So f of x is continuous on R. F of x is continuous on R. All of you know done 26, 27, 28, 29, most important problem. From this area, you will get 4 marks problem. 26, 27, 28, 29. See read the instruction carefully. Not done. Those who are not having textbook. Find the values of k. Find the values of the k so that the function f is continuous at the indicated point. Find the values of k so that f is continuous at indicated point. We have to find the k value when it is continuous. So for continuous function, what the formula we can take? Left limit is equal to right limit is equal to function value. We'll use that formula. That's all. Most important problems, immediately complete the preparation. So almost all you can answer the 4 marks problem by solving just 5 to 6 questions. Now, first problem, 26. First note on the given one. Given f of x is equal to k into cos x, by pi minus of 2x, x not equal to pi by 2. When x not equal to pi by 2. When x not equal to pi by 2, and left to right neighborhoods, we can take k into cos x by pi minus of 2x. This is equal to 3. This is equal to 3 when x is equal to pi by 2. When x is equal to pi by 2. Still question is not completed. Is continuous at x is equal to pi by 2. So read the question properly first. One function is given, conditions are given, but at x is equal to pi by 2 it is continuous. So what is the question? We have to find the k value. We have to find the k value. That's all. So already it is given continuous. So x not equal to pi by 2. At pi by 2 it is continuous. At pi by 2 function value is given 3. So to use left limit and right limit, same function is there. So direct limit value you can go for it. So we'll equating the limit value to the function value, we can find this k value. Okay. Already given continuous at x is equal to pi by 2. So just write this one. So f of pi by 2. See the function value is equal to limit value. Limit extends to pi by 2 f of x. I'm using this formula. Directly function value is equal to limit value. That's all. Move over. What is f of pi by 2 value? 3. Left hand side 3. Right side limit extends to pi by 2. Limit extends to pi by 2. F of x means k into cos x by pi minus of 2x. Now we'll concentrate on how to evaluate this limit. Cos x by x, there is no standard limit. If it is sine function, sine theta by theta, we can apply the standard limit. So this problem belongs to standard limits method. In limits, standard limits method. We'll go for it. K constant, write this one outside. So this is 3 is equal to k constant. We require that k value only. Limit extends to pi by 2. limit x tends to pi by 2. Cos function is not comfortable. Put x value pi by 2, cos pi by 2 0. Denominator, put x value pi by 2, pi minus pi 0, 0 by 0. Substitution method fails. So go for standard limits method. Go for standard limits method. Converting cos x to sine function. Sine of pi by 2 minus of x. Inside the sine function, pi by 2 minus of x is there. So in the denominator, taking 2 common, we'll get the same form. Taking 2 common. This is also pi by 2 minus of x. Now see this one. Limit theta tends to 0, sine theta by theta. Sine theta by theta is there. To applying this standard limit, not on outside. Limit of theta tends to 0, sine theta by theta is equal to 1. How to use this formula? First, what is there inside? What is there inside we have to check. Pi by 2 minus of x. Denominator also pi by 2 minus of x is required. It is there. Next, limit. Limit must be theta tends to 0. Limit must be theta tends to 0. Don't be hurry. So write this k by 2. This is a 4 marks problem. Many students, even you know the solution, in representation you are doing mistakes. As it is what we are writing on the board, follow it strictly. Many times, even toppers also, they are doing mistakes. Simply directly you are going for answer. For answer will not give the marks. Procedure compulsory. 4 marks problem. It is not 1 mark, 2 marks. 4 marks problem. Many times, many top students, they lost the marks, 100 marks. Be careful in representation from this step onwards. K by 2 constant. K by 2 constant. In hurry-burry, you will neglect the steps. Change the limit. As x tends to pi by 2, pi by 2 minus of x, pi by 2 minus of pi by 2 tends to 0. Limit of, change this limit compulsory. Pi by 2 minus of x tends to 0. Pi by 2 minus of x tends to 0. Sine of pi by 2 minus of x by pi by 2 minus of x. Many students, you will not write limit value. Sometimes you will not change the limit. You will write the answer directly. These 2 mistakes you are doing. Directly you will use the function only. You will not write limit. That is the major mistake. Next one is limit. You have compulsory we have to change the limit. Without changing the limit, if you are writing the answer 1, it is wrong. So do it carefully this step. Now it is standard form. What is there inside? Pi by 2 minus of x. In the denominator, pi by 2 minus of x. In the limit also, pi by 2 minus of x. It is required. Then only the answer is 1. So now write this standard limit value 1. So 3 is equal to k by 2 into 1. Do the cross multiplication. So k is equal to 6. K is equal to 6. So here many students are doing mistakes. You will miss the limit. You will not write the limit. Lazy. Next one, you will not change the limit. And here I am writing the 1. Here you should not write the limit. K by 2 constant. Now I am writing the answer of this limit value 1. Here you should not write limit value. Limit, not necessary. Over it is. So practice many times given problem. You complete now. 27, 28, very simple problems. Practice number of times. Find the value of k, 27th. Given f of x is equal to, kx square, when x value less than or equal to 2, this is equal to 3, when x value greater than 2, is continuous. Don't forget it, condition is continuous at x is equal to 2. This is question. We have to find this k value. Find the value of k. Given f of x is equal to kx square when x less than or equal to 2 is equal to 3 when x greater than 2 is continuous at x is equal to 2. Find this k value. You find the function value, left limit, right limit. That's all. While equating the 3, we can find the k value. See, first function value. At x is equal to 2. At x is equal to 2. What is function value? F of x is equal to kx square. Kx square. F of 2 value. F of 2 value. K into 2 square. That is 4k. Let it is equation 1. 4k. Find the left limit. Limit extends to 2 minus. Extends to 2 minus. Left of the 2, same function. Kx square only. This is also k into 2 square 4k. So left limit is also 4k. Find the right limit. A right limit is important. Find the right limit. Limit extends to 2 plus. The function is 3. So limit of a constant. 3. Let it is equation 3. Already it is given continuous at x is equal to 2. So equating right limit is equal to function value. Since f of x is continuous at x is equal to 2. So f of 2 is equal to right limit. You will get the answer. Any out of these 3, any 2 we can equate. So 4k is equal to 3. K is equal to 3 by 4. This is the answer. K value 3 by 4. K is equal to 3 by 4. So already it is given continuous. So we can use equating any 2. (28), 29 also same models. Not on 28. Given f of x is equal to kx plus 1 when x value less than or equal to pi. This is equal to cos x if x value greater than pi. Is continuous at x is equal to pi. Is continuous at x is equal to pi. We have to find the k value, this k value. Find the function value, left limit and right limit. We'll decide the k value. First, function value at x is equal to pi. What is f of x? What is f of x? Kx plus 1. Kx plus 1. F of x is equal to kx plus 1. Find the f of pi value. F of pi value. Put x value pi. K pi plus 1. Let it is equation 1. K pi plus 1. So left limit also same. K pi plus 1 LHL. So we'll find the RHL. RHL is equal to limit extends to pi plus the function is cos x. Cos xm it is. Write the cos pi value. Cos pi value minus 1. Equation 2. Since it is continuous at x is equal to pi, limit value is equal to function value. Left limit same, k pi plus 1 will get. Since it is continuous at x is equal to pi, so function value f of pi is equal to right limit, that is k pi plus 1 is equal to minus 1. See this one, k pi is equal to minus 2, plus 1 sent to right side, minus 1 minus 1. So k is equal to minus 2 by pi. K value minus 2 by pi. Complete the 29th problem, very simple problem from your side. 29th. So 29th problem. Given f of x is equal to kx plus 1, x value less than or equal to 5. This is equal to 3x minus of 5 when x greater than 5, when x value greater than 5. Is continuous at x is equal to 5. Is continuous at x is equal to 5. Find this k value. At x is equal to 5, find the function value. At x is equal to 5, f of x is equal to kx plus 1. F of 5 is equal to 5k plus 1. This is function value. 5k plus 1. Even left limit also same. 5k plus 1. Left limit also. We'll go for right limit. Find the right limit value. Right limit. Limit extends to 5 plus. Function is 3x minus of 5. Put x value 5. 3 into 5 minus of 5. 15 minus of 5. 10. Equation 2. Since it is continuous at x is equal to 5, it is given to you. So function value is equal to right limit. F of 5 is equal to right limit value. We can use this condition. So 5k plus 1 is equal to that is 10. Find the k value. 5k is equal to 9. 10 minus of 1. K is equal to 9 by 5. So most important problems, 4 problems completed. So practice once again. 30th also. Last year it is given 30th. Find the values of a and b such that the function is given by is a continuous function. 30th. See the 30th problem. Given f of x is equal to, how it is defined, note down first. Given f of x is equal to 5 and x is less than or equal to 2. This is equal to xa plus b if 2 less than x less than 10. 2 less than x less than 10. This is equal to 21. This is equal to 21 when x value greater than or equal to 10. Is continuous. Is continuous function. Is continuous function. Find the values of a and b. We have to find a and b. Just think about the question. It is continuous in its domain. At every point we have a right to take it is a continuous function. Is a continuous function. To find this a and b, see the domain is given. When x less than or equal to 2, function is 5. In between 2 and 10, function is given xa plus b. When x greater than 10, the function is given 21. So to find the a and b, two variables are there. We require two equations for a and b. One is, listen to me, at 2, left limit value 5, function value 5. Right limit value 2a plus b. 2a plus b is equal to 5, one equation, simple. At x is equal to 2, first we will discuss the continuity, we will get the one condition. 2a plus b is equal to 5. At 10, when x is equal to 10, function is 21. Right limit value 21, function value 21. But left limit value 10a plus b. 10a plus b is equal to 21. We'll solve both the equations. Do the procedure. Simple. First, at x is equal to 2. At x is equal to 2, function value f of x is equal to 5. So f of 2 is 5. Equation 1. Left limit same. Find the right limit. Limit x tends to 2 minus xa plus b, function is applying x value to 2a plus b, equation 2. Since it is continuous at x is equal to 2, it is a continuous function. Everywhere it is continuous. So at x is equal to 2 also it is continuous. So equating these two. Since f of x is continuous, f of x is continuous at x is equal to 2. At x is equal to 2. So 2a plus b is equal to 5. Let it is equation 3. We got one relation for 2a plus b. Next, second condition. At x is equal to 10. At x is equal to 10. F of x is equal to 21. F of x is equal to 21. That means f of 10 is 21. Equation 4. Find the here left limit. LHL is equal to limit of x tends to 10 minus the function is xa plus b, 10a plus b, 10a plus b, equation number 5. Since it is continuous at x is equal to 10, from 4 and 5, from 4 and 5, 10a plus b is equal to 21, equation number 6. Solving 3 and 6, you will get the a values and b values. Solving 3 and 6. See, very simple. We'll solve the 3 and 6. Take the 2a plus b is equal to 5. Follow subtraction. Plus b minus b cancel. 8a is equal to 21 minus of 5, 16. So a is equal to 2. A value 2. Put a value 2 in equation 3. We'll get b value. Put a is equal to 2. Put a is equal to 2 in equation 3. So 2 into 3 plus 5 plus b is equal to 5. 2 into 3, 6. So b is equal to 5 minus of 6 minus 1. B value minus 1. A is equal to 2, b is equal to minus 1. So the 31, 32, 33, 34, 1 mark questions. Just note down the answers. Two? 1 minute, right. 2 into 2 this is. Sorry, a value 2. 2 into 2, 4. B is equal to 5 minus of 4. B value 1. See the 31, 32, 33 based on, we discussed about F circle G. G is continuous at C. G is continuous at C and G of X, and F is continuous at G of C. So then F circle G is continuous at C. By using that property, see the first one. Now done that function. (31) Given f of x is equal to, cos of x square. See this one. X is continuous on R, so x square is continuous on R. Cos function is continuous on R, so cos of x square is continuous on R. Write that. Here it is a composite function. X square is continuous on R. Even cos function is continuous on R. And cos x is also continuous on R. That implies cos of x square is continuous on R. That's all. Over. X square is continuous on R. Cos function is continuous on R. So cos of x square is continuous on R. Same logic. Mod of cos x, 32. F of x is equal to mod of cos x. Cos x is continuous on R. Mod x is continuous on R. So mod of cos x is continuous on R. Write that. Cos x is continuous on R and mod x is continuous on R. That implies mod of cos x is continuous on R. So the 33 same model. F of x is equal to sine of mod x. Sine of mod x, composite function. Here now done. Mod x is continuous on R. Sin x is continuous on R. So sine of mod x is continuous on R. Is continuous on R. The last problem for this exercise, 34th. Find all the points of the discontinuity of the following function. What is given to you? F of x. They are asking points, find all the points of discontinuity. F of x is equal to mod x minus mod of x plus 1. Listen to me here. Mod x is continuous on R, mod function it is. Mod of x plus 1 is also continuous on R. So it is continuous on R. There is no point of discontinuity. Right, that's right. Very simple. Mod x is continuous on R, is continuous on R, and mod of x plus 1 is also continuous on R, mod x plus 1. So f of x is equal to mod x minus of mod of x plus 1 is continuous on R, is continuous on R. So there is no point of discontinuity. There is no point of discontinuity for f of x. Okay, dear students, listen to me. In the next class, we are going to discuss about differentiation, differentiability and differentiation. Most important chapter, 16 marks weightage. 16 marks. Up to now, 8 marks inverse trigonometry, 4 marks continuity. Next 16 marks. So before coming to Monday's class, all of you thorough the first year, first principle method and formula method. Here another 8 methods are there. We'll start from derivatives of composite functions onwards. Okay, Monday onwards, Mohiddin sir will take the class for you. Okay, all the best and practice all these things. Once again, a few instructions for all the students. Dear students, lockdown is extended up to May 17th. So don't come to the college. May 5th will announce the result through message. We'll send you the message. If you are having any doubt, even we'll call you. We'll give you all the details, result details. That's all. So after confirming your results, you can pay the second year fees through online or else day scholars. Anybody, you can come to the accounts office, you can pay the fees. And how many days these classes will going on, we don't know still. As per as yesterday news, as per as UGC, up to August there is no classes. So these classes will continue for you. Maybe we'll finish 60 to 70% syllabus in online classes only. After May 5th, we'll plan rigorously to go for another extra classes. Thank you.